We're solving law of cosines, or using law of cosines to solve oblique triangles. Blake, what's an oblique triangle again?
It is a triangle with no right angles.
Very good. Okay, and we're also going to find the area of oblique triangles. Those are the two things we're doing today. So let's refresh on law of sines real quick. What two types of information do they give us if we need to use law of sines?
Two angles on one side.
Two angles, one side, or what was the other one?
Vice versa. Two sides.
Two sides,
Okay, I contradicted myself by saying one angles.
one angle, and what has to happen in that one? I've got to have a match. All right, so law of cosines. There are two different types of information for law of cosines as well. What do you think? What type of information are they going to give you?
Would it be the same thing?
It's not the same thing. It's different. Nothing? First I already got it.
Why are you always comparing us to them?
Parents do your
You don't have to give it.
Can't afford to be wrong.
It's all good.
3 sides.
Three sides is one. Three sides is one of them.
3 angles.
Three angles, it doesn't help, because if it's three angles, then my triangle could be big as small as it be. There's always got to be at least one side.
One side. One side. Two sides. Two sides. Three sides.
4 angles.
One angle.
Two sides, one
17
angle,
and a half.
No
So do those sides.
no match.
Oh.
No match. Three sides, and then two sides, one angle with no match. Whenever you use law of cosines, you always get one triangle. Whenever you have to use law of cosines, you always get one triangle. Alright, so the next screen is going to show you the formulas you need to write down. So write these down for me, please. Alright, write these three down first. I want you to notice the pattern that's going on.
Oh, I see it.
That the equations get bigger and bigger.
No.
Is that just for the angles?
This right here, yes.
Okay.
These formulas are to find the angles. So angle A, angle B, angle C. Alright, so what pattern do you see, or what's something we need to notice about each one of these formulas?
Whenever the signs are plus one.
Okay, so whatever angle I'm solving for, its side is over there, and that is the only time it shows up. Okay, you need to notice these sides, each one of these sides comes down. So what we're going to do is, we're going to solve for one of the three to get started. And then to find one of the other two, we've only going to change a couple things. So once I get into my calculator, let's say I find angle A first, and then I want to find angle B next. What would I do? Right.
You just changed.
I would switch the A's and the B's. So notice if I'm going from A to B, the A is now here, and the B is now in the corner. So once I get it up there, all I've got to do is change a couple things. I've automatically got the next one. All right, so that's what you use when you're finding angles. This is what you use when you're finding sides. Yes.
Are we gonna have to
No.
Oh, baby Jesus.
All right, so what do you notice on this one?
That the match is going to be at the very end.
Okay, so those need to match these, and then my other two sides are always in that spot. Yeah, this is the exact. These are the exact same formulas. They're just solved for different things. Okay.
Okay.
The first ones. What did we solve for? The angle. Okay. So if I solve for the angle on this formula, I'd get back to the first one. Okay. Or if I solve for a side from the first one, I get to these. So they're actually the same formulas. They're just solved for two different things. All right. So we're gonna do one example of each type, and then we're going to do one example of each type of area. There's two types of areas that we're going to look at as well. So let's get started with that. All right, so our first one. Side A is 6, side B is 24, side C is 20. So we want to find angle A, B, and C. So let's set it up to find angle A first. Okay, what's inside my parentheses if I'm looking for angle A?
B squared plus C squared.
Very good. So 24 squared plus 20 squared minus 6 squared over 2 times 24 times 20. And all I have to do is punch that in. That gives me angle A. Come on. All right, so trig, inverse cosine. I want a fraction inside of it. What was it, 24 squared and 20 squared? And then minus 6 squared over 2 times 24 times 20. Press enter. There's my angle, 11.7. So we get 11.7 degrees. So now let's find angle B. So what do I need to switch to be able to find angle B? A and B. So I need to switch 24 and 6. So I go back to my calculator, I arrow up. Everywhere I see a 24, I need to put, and everywhere I see a 6, 24. So I replace that with a 24. replace that with a 6 and replace the one on the bottom with a 6. And I get 125.7. And add and subtract to get the other one. So that is 137.4. So that's 42.6. So I get 42.6 degrees. So pretty much just choose an angle to use, punch it into your formula, use your calculator, figure out your next angle, and then all you've got to do is switch what? Just switch your two sides, whatever one you're using. Put that in there, you've got your next angle. Once you have two angles, you automatically get the third. Question on that type. Alright, let's look at the other one. Alright, angle C is 65, side A is 5, side B is 11. What tells me that I have to use law of cosines? No match. No match. So I want angle A, angle B, side C. So what do I need to find first?
C.
Side C. Side C. So that is a squared plus b squared minus 2ab and cosine of c. So 5 squared plus 11 squared minus 2 times 5 times 11 and cosine of 65. So 5 squared plus 11 squared minus 2 times 5 times 11 times cosine of 65. 9.975. Alright, so once I find that first side, what do I now have?
3 sides.
I have a match. And when I have a match, what can I use?
Sine.
Sine.
Do you have to use sine?
You do not have to use sine. You can still use law of cosines if you want to. I recommend law of sines though. However, you have to be careful on which angle you choose to find if you're using law of sines. If you start a problem with law of cosines and then you switch to law of sines, you always have to find the smallest angle first. So which angle is going to be the smallest? A. So I need to find angle A. Okay. Lauren, set it up for me to use law of sines to find angle A, please.
Sine of A over 5 equals sine of 65 over 9.975.
Very good. So we want to get A by itself. So I'm going to have inverse sine of 5, sine of 65 over 9.975. And I want to show you something, so don't put it all the way in just yet. So the top was 5 sine of 65. And on the bottom, it is 9.975, which is this decimal right here. Okay, to get the most accurate answer, I want this in that spot down here at the bottom. So what can I do to put it in that spot? There you go. I want to use Control and this button right here. It will take the previous answer and put it wherever your cursor is. So I press Control and it puts that answer, that previous answer in that spot. That way my answer is as accurate as possible. So we're going to say angle A is 27. And add, so that gives me 92. So I end up with what on the other angle? 80. 88 is my other angle. So that is law of cosines. It's pretty much just punching in the formula and getting your answer out. That's all there is to it. But again, if you start with law of cosines and then you end up using law of sines, which angle do you need to find first? The smallest. Find the smallest. Because if you find the biggest and the angle is supposed to be obtuse, sine will not give you an obtuse answer. All right, now let's look at the area formulas. All right, so this is the information I have. Side A is 4 feet, side B is 5 feet, angle C is 84 degrees. We want to use that information to find the area of this triangle. The formula we need is area equals 1/2 AB sine of C. Area equals 1/2 AB sine C. And there are actually 2 other versions of this formula. What would the 2 other versions be? 1/2 BC sine A and 1/2 AC sine B. Okay, but notice what's the information that you have? What kind of information did they give you? 2 sides, 1 angle, and
Sine C.
no match. 2 sides, 1 angle, and no match. You use this formula to find your area. So all I have to do is plug in. So area is going to be 1/2 4 times 5 sine of 84. So that's going to be 10 times sine of 84. So we get 9.945. What do my units need to be? Feet squared. Why is it squared? You're finding area. So feet squared. So you just plug in, use your calculator, you get your area. Alright, one more area problem. So this time we're going to get 3 sides. Side A is 13, side B is 12, side C is 8. The area formula we need, whenever we're given 3 sides of a triangle, is called Heron's formula. It is area equals the square root of S times S minus A times S minus B times S minus C. S is A plus B plus C over 2. For this problem, yes. You use Heron's formula whenever you have 3 sides. So in order to use Heron's formula, what do I need to find first? S. So S is going to be 13 plus 12 plus 8 divided by 2. 33 over 2. So 33 divided by 2, make it a decimal, so 16.5. Now, what can I use instead of 16.5? If I didn't want to type in 16.5 each time, what could I use on my calculator?
Answer.
The answer button. Good. So that's the best way I like to do it. I like to do answer minus 13, answer minus 12, and answer minus 8. If punch it in that way. So 13, 12, and 8. So get my square root. I'm going to have answer times answer minus 13 times. Is that what I want?
Yeah.
Let's do the parentheses. I don't trust it. So let's do parentheses, answer minus 13. Make sure you get out of the parentheses. Get yourself a new parentheses. Answer minus 12. Get out, new parentheses, and answer minus 8. Press enter. 46.999. And units on this? Meters squared. So we use Heron's formula to find the area of a triangle when we're given what? 3 sides. Okay, so pretty much everything we did today requires what? A formula. So if you can plug into a formula, you're good to go on today. So that's law of cosines. Using law of cosines to solve an oblique triangle. Matthew, what's an oblique triangle?
It's a triangle about 90 degrees in it.
Very good.